Hey, welcome everybody. Thanks for joining in. We are in the midst of well, I guess the worst of the heat wave is pretty much over with in Montreal and sort of northeastern United States, but still pretty warm up here. And my printer had a really difficult time because of the humidity. The filament got all moist basically, and you know it really gives bad results when you 3D print. You get some bubbles and some just general crappiness trying to get the plastic out of the nozzle. The vapor basically you can see the vapor exiting the nozzle, and it creates, instead of a smooth laminar flow of plastic, you get these bubbles and stuff and these interruptions in your prints. But I built a dry box, which I can show you here. I used the very popular Becky Stern video online as inspiration. I made a few tweaks there. I'm still waiting on some Teflon tubing to run out of the dry box all the way to the printer. But in the meantime, I just kind of retract the filament when I don't use it. Seems to work fine so far. And this has allowed me to crank out two pretty nice switch parts on which I mount the switch inside the keyboard. The quality is pretty good, actually, not too bad. I don't know if the camera will do this. I can manually focus, but is it gonna wake up before I have to do so? All right, let me manually focus then. Here we go. You can see the quality is not so terrible on it, and all the holes are kind of well formed and everything, which I was definitely having a lot of issues with before I built the dry box and dried out my filament. Oh yeah, I forgot to mention that. So a lot of people try to dry filament in an oven because you basically set it at super low temperatures and you let your filament in there, hopefully in a convection oven or something. And the idea is basically it's supposed to be a very dry environment and it's supposed to wick the moisture out of the filament. And, you know, no miracles, but it's supposed to bring it back into a good state. Now my oven actually doesn't go low enough. Its lowest temperature is higher than the class temperature, PLA, so that would have been no good. I would have ruined my spools right there. But I do have a fancy schmancy dryer that has a rack for drying shoes, which means that you can put stuff in there and it's not going to rotate as the drum rolls. And so I did that. Actually, I was able to put two spools of filament and a big loose ball of filament that was given to me, and it had a pretty good effect. I would say brought it back maybe 70%, 75%, something like that. So not perfect, not factory fresh, but still pretty good. And then the dry box is keeping it in that condition, and it's certainly not hurting over the long run to have it stored in a super dry environment. All right, so in theory, I haven't done, other than trying to get the printer together, I haven't done a lot since last time. I've made some very minor tweaks to the 3D model for these parts that are, let me just quickly adjust the camera to make it a little lower. Yeah, so I made a few tweaks to the models here, nothing dramatic, just some little moving some lines here and there left and right. And what that means is that I've got 18 switches here and 18 places to put them in there, and I should be able to assemble these in the keyboard and line up properly. There we go. Once the switches are actually in there, these two pieces hold together, and then there's a screw hole here that fits an existing screw post inside the keyboard, and it stays in place. And I've triple checked the PCB design. It should match what I had before. So what I was hoping to do tonight was check mechanical fit, make sure everything fits properly inside the keyboard shell and that it doesn't move and there's no rattling or anything like that. But in theory, that should be good. I'll check that on both sides of the keyboard, be sure that everything is absolutely perfect. Then I would like to put the copper tape on these PCBs here, this one and this one, and then actually make the PCBs. So cut out the little lines, basically break the traces apart, and then we'll see how late that gets me. And then possibly start soldering some rainbow cables to this. If I can get the rainbow cables soldered properly, then I can actually hook them up to the keyboard's motherboard right there. We could actually plug the keyboard in, and then we could test it, which would be awesome. That would be very, very nice. All right, so without further ado, let's see if we can't get the mechanical assembly done. So I'm going to start fitting switches into these holes. Uh-oh. Have I lost sound? I may have lost sound. Give me a sec. Uh-oh. Uh-oh. Did I lose you guys? No, alright. All good. Sorry about that, false alarm. Alright, put on some more music. I have to keep music on because otherwise I can't tell if my sound card conks out. Start fitting some switches in here. I actually took a bunch of these. I should double check, make sure all the pins are straight. Took a bunch of these out of my previous prototypes and I accidentally bent a few pins. Okay, so they all look good except one. Let's straighten this one out. Alright. I'm actually gonna use some pliers for that. I have great plans to construct a kind of tool organizer based on Adam Savage's first order retrievability theory. It used to be that I thought that in order to have a proper tool storage solution, I'd have to trade up space. Like I'd have to give up space to get more accessibility in my tools. But since watching some of Adam Savage's videos online, I've actually realized that it's kind of the opposite. You can increase tool storage density if you organize it properly. And that means you can kind of have your cake and eat it too. If you're smart about how you store your tools, they can be easy to retrieve and also take up less space than under alternative arrangements. Let me just open the door, my cat's going crazy. Allô, non. Ouais, tu veux rentrer? J'aime pas ça quand la porte est fermée, hein. Tu veux rentrer? Come on in. I'm not sure. She's a TV star. Little fluff ball. How's it going, cat? You want to help me? All right. There we go. The fluffiest of helpers. Yes, you like that, don't you? She's extremely careful with everything. She never knocks anything down, except maybe when she jumps off the table, which she's about to do, I think. Alright, there we go. Boing. And I've satisfied her curiosity. Back to putting switches. I'm very excited to try this out because I was explaining to a coworker today and good friend. Oh wait, I got a hole to remount here. That not having these function keys work is really a pain in the butt, especially for programmers. We use these tools, these keys all the time, right? And I was telling my friend that so the failure mode of the tools that the keys that I currently have is that they either don't register or they register an arbitrary number of times, you know, where n is between 1 and 5. So, well, generally 1 and 3, rarely 1 to 5, but it does happen. And so what that means is if you're, you know, searching through a document and kind of leafing through the hits looking for maybe a little bit of a specific function or, you know, a specific piece of code or something, then that noise is great. Then it's difficult because you actually sometimes the sort of double or triple hit occurs so fast that it just streams right past your face. And you have no clue. So sometimes the search wraps around, and I'm like, wait a minute, I'm sure there was another hit, you know. And then I go and I do it again, and then I get kind of different hits because I I get different numbers of presses with my F3 or my F8 or whatever in Visual Studio. So yeah, it's a bit of a pain. There we go. There we go. Oh, I see something now that I hadn't noticed before. I'm going to try to show this on camera. I have to pull in a really tight focus here. Okay. Can you see around the big pins, there's kind of a chamfer effect. The plastic is being raised, which is not desired. That's a sign that my hole is not big enough. It doesn't. I think it seems worse at this end. Yeah, you can really see on this big post right here. I think that'll work out, you know, as I can kind of push it back down or whatever, but certainly wasn't part of the plan. In fact, I think when I put the PCB on it, alright, I'm just going to ream some more holes there. When I put the PCB on it, that might help flatten it out, and we'll see. If not, well, I'll just revise the design and make the hole bigger. Sorry, I should switch that back to manual or automatic focus. Sorry about that. Just some more reaming. All right, this looks pretty good actually. Oof. I hear little bits and bobs snapping. Might have to loosen the fit on these things or ream them out further. Oh boy. Oh man, it's going to be hard to take apart if it fails. I think I'm gonna have to make the. Woo. And I say that, I actually need to take it apart to poke the holes for the PCB and stuff as well, but whatever. Alright, let's just do the mechanical test. Yeah, these holes definitely need to be bigger, a little bigger. Pins are not so bad, it's really the plastic posts that are giving me grief. Oh man. Alright. don't want to break the switches either. Oh man. Alright, let me... Can I ream this out? Alright, I'm gonna get a bigger drill bit. Give me a sec, I'll be right back. I'm back. Brought tools. I think I could start with this drill bit. All right. This was like the tiniest of reams. The slightest. Wait, did I ring the wrong thing? I did. I ring the wrong thing. Bravo. All right. Let me move this over. It's a little better. It is actually a little better. It's not perfect, but it's actually noticeably better already. All right. So, yeah, I'm gonna go and ream this with a slightly larger drill bit. Alright, here goes nothing. She had, oh, there we go. Very small piece of sandpaper just to get rid of the burrs. There we go. Let us try this. All right, this is much, much better. All right. Yeah, it's better but not perfect. I think I will actually need another round of printing before final assembly. Unfortunately, I'm going to need to make. Oh man, I need to make this a little thinner if I can. Just a very tiny little smidgen. All right, but I do have an assembled switch tray. Let's see what gives. All right. Let's grab a screw in this box. Number 5 screws. And then put the switches in the right place, of course. This fit is very nice. All right. Oops. And let's close up the shell. Right side up, please. Right. So, this doesn't look half bad. Focus that for you. There we go. Boop. That gives you an idea. They're all pretty well aligned, actually, in front of the holes. In fact, they are quite well aligned. I'm impressed. And do they move at all? They seem like they won't at all. I mean, wow, this is really solid. Oh, I can start feeling this project coming to an end. I'm so happy. Not that I don't like the project, I need these keyboards. Alright, let me pop a couple of key switches in there, keycaps in there if I can. The only thing is I have I have a few keycaps, but I'm not sure. I have a few variations in there, so I'm not sure which was which, really. Oh wait, I might have gotten rid of the ones that I didn't like. Okay, are these all the same? Do they all look the same? Do I have 9? Yeah, I do have 9, so I think these are actually all the same. Okay, let me just check. They are all the same. Alright, so let me try to put some keycaps in there. This is the hardest one, obviously. Oops. My friend has an Advantage V2 at work, which if you remember, have these switches in them already. And I'm wondering how much of a clearance there is between the keycaps and the holes, to tell you the truth. The clearance isn't perfect here. Some of them they rub against the case. I wonder if that's an artifact of like bad assembly or Maybe just need to redesign the keycaps, actually. Much easier to design if the hair is systemic and they're all offset in the same direction. Easier to design the redesign the keycap than it is to redesign the switch box. And it actually looks that way. Okay, so they all do rub a little. Oh, this one's broken. Great. All right, so it's normal that it's kind of not doing a great job. Okay, let me just quickly see what's going on here. Oops. Yeah. So the mounting plate is not moving at all, like at all. But you can kind of see, let me move the keyboard out of the way. That, trying to show this with the light there. It's super black. All right, there we go. Okay, there we go. I don't know if you can see this, but there's kind of there's no gap on the bottom. This is the bottom upside down. There's no gap on the bottom, and there is a gap on the top. So what I'm going to do is I'm actually going to shift the keycaps a little bit up so that they clear the holes properly, which is much easier than redesigning the switch box. I mean, it's going to be like, you know, 0.5 millimeter or something move, so it's not going to affect the balance of the keys or anything like that. But this is really nice. This really fits like super nicely. And this key here in particular feels really nice. I mean, they all kind of work. I suppose I could redesign a switch box. Could move it up by like, move the gap up or move the keys up. I mean, if I have to redesign the holes anyways. All right, so let me make notes here. Little notes. All right, thinner PCB, move switches up a tiny smidgen. What else was there? Yes, slightly bigger plastic post holes, so I don't have to ream them. And then, I mean, as far as the rest of the design goes, I mean, it's pretty solid. I feel that you can see these legs here, here and here. They actually rest against this back shell here. I iterated on that a couple times, and it really feels nice and tight now. When I close this up, I can push on these buttons, no problem, no movement at all. I mean, right now they rub a little bit, so you can feel that buzz because it's the layers of plastic, but otherwise they feel the same as my friend's keyboard because it's the same switches, right? It's the same mechanicals. So, all right, I think I'm gonna put together the other half. Have a quick glass of water. It is really hot. All right, but first, let me ream some holes. a few small holes I need to ream as well. Easily done by hand. I wonder if there would be a way to test the logic for this board without having to solder. Suppose I could just, I'll think about that. All right, more reaming here. The reason I do this with a hand drill is because the hole is very small and the bit is very delicate. I don't want to snap it with my power drill, though it is the biggest of the small bits that I have, so maybe it would survive being handled by a power tool. I bought a circular saw recently, a nice DeWalt. Let me show it. Very nice. I had no way to make straight cuts before. I only had a Bosch jigsaw, which I love, but I mean for long straight cuts, you know, I have no space for a table saw here, unfortunately. But a circular saw hopefully will do a pretty good job with a good clamp or a guide or something. A good clamped guide, I should have said. All right, so back. So the idea with the circular saw is to build the aforementioned or some aforementioned tool storage implements to make to improve my life organization wise, tool organization wise. All right, let me just sand this off a little bit. All right, let's snap some more switches in. I have to be careful when doing this not to bend any leads or anything like that. Oh, see here the plastic actually cracked because the hole's not big enough. So there you go. I don't think this would impact the integrity of the. I mean, this the plastic sheet quotes. Oh wow, it actually broke clean there. At the bottom of this is it doesn't really play that much of a structural role. It's mainly there to just register with the PCB properly. Sorry, I'm just straightening out a pin here. There we go. Oof. Yeah, definitely need to make this hole a little bigger. Just a smidgen. Another thing I want to do on the printer actually is to put the auto level sensor, because this would actually help with the reproducibility of this fine detail. Right now, when I manually tune the distance of my print head to my print bed, a little more, a little less means a little less, more or less squishiness in my plastic in my first layer. And it means that some of the details kind of get smudged out, which normally for typical models is not a huge problem because you're not chasing tenths of millimeters. But for this kind of like super precise work, you should see what the first layer on these looks like. It's just the printer spends like 15 minutes drawing little circles, because it has to draw a little circle, actually 2 little circles for every hole in this thing. And in my case, I think actually I set it to just 3 contour lines right now, so it spends a lot of time doing that. All right. Putting the PCB in place. just snapping things together. Man. Yeah, it needs to be a little thinner because otherwise the pins on the switches barely stick out through the back. And I need to solder to them, so it's already like, I thought it was the thinnest I could make it, but looks like I'll have to go even further. Oh man. All right, but second half of the keyboard. Screw this in place. There we go. Go. Nice and tight, not moving anywhere. This is the moment of truth. If this doesn't line up properly, then I'll need to make the keycaps a little smaller so that, man, it lines up so great. Unfortunately, I only have 9 keycaps. And one of them is broken. So I'll have to take apart the keycaps on this side. I have to pull them out. There we go. And move them to the other side. Now if you're wondering, are the keycaps going to be this easy to pull out on the final product? Probably. I mean, the harder they are to push in, the harder they are to pull out, but they are pretty hard to push in at this point. It already. Yeah, it looks similar on this side. I think they could stand to be moved up a little bit. This side actually feels really nice. I mean, it's such a little slight adjustment. Oh man. But yeah, they can move up a little bit as well. Oh, this feels so nice. Oh man, I cannot wait to finish it. Oh man. Yeah, this is the broken one. Doesn't matter. This is gonna be sweet. Alright. Okay, let me pull this apart. Check it out. It's so nice. Check it out. Stays in place and everything. When I'm done, it'll all be little rainbow cables and everything too. It'll be cute, even on the inside. Alright, so I'm going to take this apart, and then I'm going to try to put the copper tape on it. Make sure everything works as designed. Yeah, it's not too thin or anything like that. Yeah, these come apart pretty easily, but once it's done, it's going to be soldered together, right? So they're not going anywhere. Okay. I have a piece of copper tape right here. And then have X-Acto, which will help me. Actually, this is like the exact right length. This must be from a previous previous piece. All right, I'm going to try to pull away the backing tape. Oh, sorry, crap. All right. They wanted to avoid creasing the tape at this end when I pulled away the backing tape or the backing, whatever, backing cardboard. And I kind of rolled up the tape there. Oops. All right. All right. All right. Use my trusty eraser to run this over and really bring out the ridges and stuff. Zoom on this, it's worth it. Check it out. You can really see the difference before and after. This corner here has been erased and the rest has not. Let me continue and you'll see what I mean. Just for a little bit there. Check it out. Erased, not erased. So you can really see quite well through the tape once it's been erased. And I use a small eraser for this. It's a very small one. It might work with a bigger one, but I figure a small eraser, I mean, it gets to all the details, you know? All the little details. Maybe a bigger one would work too. You know what? I wonder if I have one lying around. I do not, unfortunately. But I mean, it's not like I have, you know, 10 square kilometers worth of copper to process, so to speak. All right. Yes, there's another slight change I wanted to make to this, which is, let me make a note, I added last for the copper tape. I wanted to add one extra groove at the very end. Though I suppose, I'm not sure whether I really need it, to tell you the truth. All right, so let's start cutting. Actually, probably I should poke the holes first. I'll do that. All right. Part's a bit long, but it's all right. It means, you know, short runs of PCBs, no chemicals, and no super precise CNC required. And I think it's worth exploring. I mean, you work with what you got, right? I have a 3D printer, I have a laser engraver. It's only 2.5 watts. It's not super powerful, so it's not enough to like vaporize what's the word I'm looking for on PCBs, the thing that prevents the etchant from doing its job. That word slips my mind. Resist. There we go. Not powerful enough to vaporize resist. So there we go. Another thing I like with this technique is you could actually build, you know, some 3D circuits with this. Like you could print a 3D structure as long as you can stick the copper tape on it. There's nothing preventing your traces from entering the third dimension, right? When you think about it, right, if you've got to agitate your PCB and clean it up and all that stuff, I mean, there's still a bit of processing time involved with other techniques too. All right. Getting there. All right. Time to test this. So far, surprisingly, I haven't had a single failure, but there's always a first, right? It's pretty easy to correct with this technique. If there is a failure, it'd be pretty simple to track down. All right. Oh man, I'm outside of frame, sorry. I'm just testing with the leads, basically. No failures. So what do I do with this? Do I solder something up to it and then test it with the motherboard? That'd be a lot of fun. Okay, what do I need to do here? No, I don't think I need to solder anything. What I could do is I could verify at least the logic. I could verify the logic by using little female to male leads and then touching the parts to simulate the key presses. Got a rainbow cable here, female to male. I could use it to test this. It's the only one I have, but I don't really mind splitting it apart. Oh, you know what I could do? I have female to female test leads somewhere. I'm pretty sure. There we go. I will do that instead. Keep my rainbow cable for another day. Okay. Here are my female leads. And I needed, how many was it again? At most, I think it was 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I was quite wrong. All right. So, how many colors do I have? 2 black, 2 red, 2 blue, 2 yellow, and 2 green. That's 10. And then an extra red because I like the color. All right, there we go. And then let me grab some long leads, hopefully in matching colors. Okay, let me these are a lot of test leads I had made for a previous project involving lots of radios talking to each other. All right, so black. This is good. And red. I might have to go orange for one of the cables, I think. For the third one. Yeah, okay. Don't make it orange. Close enough. Then 2 yellows. 2 greens. And 2 blues. All right. Put this back in here. And then, all right, let us assemble these leads. Actually, you know what? Let me get some water. I'm dying in here. All right. Let us assemble these cables. Long blue cable. In case you're wondering what that sound is, it's a fan that I was using to cool my 3D printers at work, because my actual 3D printer cooling fan is dead. And so I'm using a box fan instead. Doop-de-doop. Uh-oh. Did I screw something up? Oh, I think I took out one too many black leads. Alright, I'll leave that here. Okay. Now, for the moment of truth. Okay. Screws on this end. That means it's this side of the keyboard, which was originally matched with this PCB. Okay. And then these connectors were, okay, pin. Okay. So there's no fancy ordering going on here. The top pin is the top pin on the PCB is the top pin there. And the bottom one is the bottom one there. All right. Oh, this is exciting. This is very exciting. And see, this is why you double check everything, because actually this goes on the other side. There we go. Thought something looked wrong. Okay, I'm going to wire these up. Red, black, red, green, blue, oh wait, I don't even know, I actually only pulled out the right number for the number of leads I need. And on this PCB they happen to be all the first ones. Okay, all the top pins, so red, and then yellow, and then black again, red, green, blue. Yellow. And then red. Okay, got a nice little mess of wires here. And my goal this was totally screwed in originally, but now I could actually just connect it to this daughter board. Okay, now the goal is to first clean my work surface, make a bit of space. Be very happy if I can get this to work. What I need though is my layout. For this left side PCB. PCB left. Actually, it's the right side PCB when you look at the keyboard from its face. Yeah, that's not what I want. PCB right. Okay. All right. So the next thing I want is a program that can display when certain keys are hit. Now there's one out there that I used recently actually at work to test my keyboard. This is the one. I think this actually rings a bell. No, I want an actual tool. Now, yes, there was an evaluation for this, but I found an actual free one. I seem to recall getting it from that page, though. Going in circles. Oh wait, sharp keys. No. That seems to work. Oh, very interesting. Keyboardtester.com. Over 6 months on the internet. Monophonic key sound experience. This is really tongue-in-cheek. This is pretty funny. Alright. Okay. Let us plug the keyboard in and see what's going on here. Alright, let me make some more space. Oops. Keyboard tester. Alright, I actually need the space up here. Goes like that. And there. Whoa. Because it's sitting on its face. All right. All right. Okay. So. Okay, well, it's not dead. That's good. Motherboard still works. All right. All right. All right. Now, let's see. Oh, that's a bit small. Okay, so this is seen from the back side. The first key should be top wire, so that's this black one. Probably shouldn't be letting these all loose, but and then that is this switch. This should be, what was it in the original keyboard? I think it was like, these are actually special function keys. This is programmed, so I can't really test that one. Keypad I could test, but the LED's on the other side. Pause, break, scroll lock, print screen. 1, 2, 3, 4, 5. So print screen should work. So print screen is a 1, 2, 3, 4, 5. It is the 5th key. So purple, which is the bottom one, and then green, which is the 3rd from the bottom. Okay, so bottom one, that is this. Uh-oh. And then 3rd from the bottom, which is blue. So if I push this, if I touch these wires together, in theory, that should count for a print screen. I should get a, and it works. Very nice. Okay, getting there. So 1, 2, 3, 4, 5. These together, and then boop. Okay. Yeah, this looks good. Just make sure screenshot didn't mess with my stream there. All right, sounds good. This is encouraging. All right, to the left we have F12. Now F12 was 3rd from the bottom, And then that is 5th from the top. So 3rd from the bottom is the blue one. 5th from the top is this yellow key. Okay. That should be F12 in theory. Double check. 3rd from the bottom. 5th from the top. That's F12. Alright. Then F11 should be 5th from the bottom and 6th. Okay, so 5th from the bottom is this. And then 6th is this. F11. F10 is 6th from the bottom. And 4th from the bottom. So that's this guy. And that's correct. And then F9 is 1, 2, 3, 4, 5, 6th and 7th from the bottom. 6th and 7th from the bottom. Whoops. How does this look? Looks perfect. This is amazing. This is great. I'm jazzed. I am truly jazzed. I'm not sure how to test the actual PCB though, short of soldering the switches to it. But this is good news. It means at the very least that these headers were soldered on properly, though I haven't tested all the keys. Scroll lock I don't really use. Pause break I use once in a while with control. I know Windows, yeah, there we go. Scroll lock. What actually detect scroll lock? We could try it. Print screen scroll lock. So scroll lock is 4th. So that is 2nd from the bottom, 3rd from the bottom. So let's scroll lock. All right. And then pause break would be 4th and 5th from the top. Yeah, 4th and 5th from the top. So that's these two guys. Is that right? No, sorry, that's this. These two guys. That is pause, and it works. So keypad is not going to be detected by this tool. Program I won't be able to display either, but keypad I should hear the buzz. Actually, I should hear the buzz in both cases. Yeah, I should hear the buzz in both cases. The little correct. A little key click. Key click is the word I'm looking for. So 3rd from the top in both cases, and then 2nd and 1st from the top. That's 2nd and 1st. And there we have it. There we have it. That 3rd light though, that is that keypad? No, it's scroll lock. I'm very happy. I think the next step is to print a new set of parts with the slight adjustments I need to make, and then just go for it, solder everything up. All right, it's getting pretty late. I think I'm going to try to get some rest. But yeah, thanks for hanging out, and hopefully the next time we hang out, I'll have some proper final assembly going on. Should be a good time, and I look forward to it. All right, have a good one. Take it easy.